Hi, hello dear friends, welcome back once again to our channel Vagay Academy of Mathematics, and this playlist is where you will find video lessons for CAT, MAT and other management exams. So this session we again have an interesting question from the concept of progressions. Let us see what question is here with us. Yes, so here we have find the sum taken up to infinity. We have an interesting series given here. So we have 4 by 11 power 1 plus 44 by 11 power 2 plus 444 by 11 power 3 plus 4444 by 11 power 4 and so on. So this is the series which is given to us and for which we are supposed to find the sum up to infinity. Okay, all right. Yes, we'll note it. And yes, if we have a quite observation, okay, if we just try to make a small observation here, this given series is following some interesting pattern. Yes, okay. Although we are able to predict the pattern this series is following, we need to do some technical, very interesting steps in order to solve this problem to get the answer. Fine. Yes. Yeah. I think now we'll just get into the approach how we can solve this problem. Yeah. Fine. So let us just take this infinite sum to be equal to S. We'll notate it as S. So S is going to be equal to, we'll just copy the same series here. What is given here, we'll just copy it here. So we have 4 by 11 power 1 plus 44 by 11 power 2 plus 444 by 11 power 3 plus 4444 by 11 power 4 plus and so on. So this is what we have here in the series. Let us just observe each of these terms here. Okay, all right. Now, if you see the first term, we have 4. That's only 1 4, and that is divided by 11 power 1. Now, when you see the second term, we have 44. That is, there are 2 4s, right? 4 4. There are 2 4s divided by 11 power 2. And next third term is going to be obviously 3 4s. There are 3 4s, 444. 3 4s divided by 11 power 3. And next fourth term is 4 4s divided by 11 power 4, and this is the way this series is followed, right? Yes. And now if you see here, it is very easy for us to predict what can be the nth term of this series. I think by this time we would have predicted. So our nth term of this series will be of the form, definitely it will be of the form force. I mean there will be n force in the numerator, and that will be divided by, that value will be divided by 11 power n. That is what will be the nth term, right? Yes. Yeah, it is easy for us to predict, but anyways, we are asked to find the summation. All right. Yes. Yeah. Now the first step itself, I'm going to do a kind of rewrite. I'm just going to adjust the terms something like the following, what I'm going to do. Okay. All right. Yes. Now just listen carefully. What I'm going to do here is, anyways, we have got all 4s in the numerator part, right? So for that reason, let me just factor those 4s out. So once I do that, I will be having 4 taken out, and what I will have inside is, I will just simply have 1 by 11 power 1 plus 11 by 11 power 2 plus 111 by 11 power 3 and so on. This is the way I will be getting, right? If I just factorize that 4 outside. Now simultaneously, I'm just going to do another thing. What I'm going to do is, I'm just going to divide by 9 also. Right? Yes. So you may wonder why I'm doing that, but just listen carefully. For a reason is what I'm just doing this. Okay. All right. Now, once I divide by 9, what happens is, each of those ones what we had there will be multiplied by 9. Okay. All right. So that you will end up with 9 by 11 power 1 plus 99 by 11 power 2 plus 999 by 11 power 3 plus 9999 by 11 power 4 and so on. So this is the way our series is going to be rewritten. Okay, I hope you are able to understand this. So what we did here is simply I just factored the 4 out and divided by 9. The reason is I'm just going to rewrite all these 4s as 9s. That is my objective. Okay, all right. And if you are following our channel, we would have seen a similar kind of question in our one of those previous videos. Okay, maybe if you have missed that series video, I'll just attach the link of that video here in the icon of this video, maybe here. So it will be useful for you to see that video. Maybe once you see that, you will get a better idea in following this problem. Okay, all right. Yes. Yeah. Anyways, continuing. So we have rewritten our series like this. Now again, what adjustment I'm going to do here is I'm just going to write it as 4 by 9 into. Now again, if you see, now each of these numerators are in the form 9, 99, 999. I mean, all of them are in terms of nines, right? Yes. Now I'm going to do another adjustment here. What I'm going to do here is each of these numerators I'm going to rewrite. Okay. How I'm going to rewrite? If you ask, these numerators I'm going to rewrite like this. First 9 will become 10 minus 1 by 11 power 1 plus this 99 I'm going to rewrite it as 100 minus 1 by 11 power 2 plus this 999 I'm going to rewrite it as 1000 minus 1 by 11 power 3, and obviously this 9999 can be rewritten as 10,000 minus 1 by 11 power 4 and so on. I hope you are able to understand this. Yeah, fine. Now each numerator I have just rewritten like this. Now you see here we have 4 by 9 into. Now if you see here, we have got all subtraction forms in the numerator. Now we are going to just resolve, or we are just going to split these I mean each of these fractions as two different fractions. Okay, yes. Like if you see, we have 10 minus 1 by 11 power 1. This can be rewritten as 10 by 11 power 1 minus 1 by 11 power 1. Is it or not? Same way, if you take the second term, this can be rewritten as 100 by 11 power 2 minus 1 by 11 power 2, and following here, this will become 1000 by 11 power 3 minus 1 by 11 power 3. This is how it follows and so on. Okay, all right. So this is the next step we are going to perform, and that too, let me collect all the first terms of these fractions and all the second terms of these fractions. Both separately we will try to do that. Okay. I think if I write it, you will be able to understand even more in a clear way. Okay, all right. So yes, so how I am going to rewrite it is, just listen carefully. This I am going to write it as this 10. Okay, 10 by 11 power 1, and next here we have this one written in the form plus 100 by 11 power 1, 11 power 2. I'm sorry, 11 power 2. Next we have this 1000 by 11 power 3 plus here we have 10,000 by 11 power 4 and so on and so on. And next minus, separately a minus. Next we have, now I'm just taking this minus as a common factor outside. Why? Because all the corresponding second terms do have a minus. For that reason, I've just taken that minus, entire minus. And now what we will have inside is, we will simply have this 1 by 11 power 1 plus this 1 by 11 power 2. It is no more minus. Okay, we have just taken that minus outside. So for that reason, we will simply have 1 by 11 power 1 plus 1 by 11 power 2 plus 1 by, here we will have 11 power 3 plus 1 by 11 power 4 and so on. This is what we will be having. And now if you clearly see, here we have one expression minus here we have got another expressions. And now if you look, both of these expressions, both of them are going to be none other than GPs. They are going to be geometric progressions. If you clearly observe, you can easily realize that, you can easily observe that. Okay, yes, if you see this first, this expression, here we have 10 by 11 power 1 and this is 100 by 11 power 2, and here we have 1000 by 11 power 3, and here we have 10,000 by 11 power 4 and so on. Is it or not? These are nothing but, they are nothing but, let me rewrite this, just they are just going to be nothing but, the first term is 10 by 11 plus the second term, this is nothing but 10 square by 11 square, and the third term is 10 cube by 11 cube and so on. And next minus, let me open the second bracket. Here we have 1 by 11 power 1, or simply it is 1 by 11 plus this is going to be 1 square by 11 square, and here this is 1 cube by 11 cube and so on. This is what we have here. I hope you are able to understand that. So that means clearly this is a geometric progression and also this is a geometric progression. So clearly we have got two GPs which are individually taken up to infinity. That's it. Okay, fine. Now if we are clearly able to simplify these GPs, then we can easily get the answers. Okay, fine. Yeah, I think you can take this space to solve those GPs. Okay, they are not going to be much complicated. if at all we are aware of GP's formula, we can easily solve it. Okay. Yeah, what would be the formula for GP, or what would be the sum of all terms of a GP when the sum is taken up to infinity? That we have to think, right? So what is the sum up to infinity? The sum up to infinity is nothing but a by 1 minus r, is it or not? So where a is going to be the first term of our GP and r is going to be the common ratio of our GP, right? All right, yes. So that means this expression will become what? This is a GP where the first term is 10 by 11 and common ratio is again 10 by 11. Why? Because you can easily observe it, right? So I have 10 by 11, that is once again multiplied with another 10 by 11, that gives you the second term. And this is again multiplied by 10 by 11, that gives the third term, and so on. So here this first expression is a geometric series with first term 10 by 11, I mean a is 10 by 11, and second term, this second GP, here if you confirm. So here also, this is also a GP whose first term is 1 by 11. And when you talk about the common ratio here is 10 by 11. And here about the common ratio, here it is again going to be 1 by 11. Is it or not? Because 1 by 11, we have 1 square by 11 square. That means this is getting multiplied by 1 by 11. I mean the first term is getting multiplied by 1 by 11 to give you the second term. Second term is once again getting multiplied by 1 by 11 to give you the third term, and so on. Okay, all right. So maybe for a comfortability, I will take this expression as S1. Okay, so that means our S1 value is going to be A is 10 by 11. So 10 by 11 divided by 1 minus R. 1 minus R will be nothing but 1 minus our R here is going to be again 10 by 11. Is it or not? So 10 by 11. So this will give you 10 by 11 divided by, what about 1 minus 10 by 11? I think that is going to be 1 by 11, is it or not? Because this is going to be 11 minus 10, so 1 by 11. So this will simplify to simply 10, because this is 10 by 11 by 1 by 11. You can cut this 11, so you will simply end up with 10 for S1. So that means here we have 4 by 9 of this first expression will be simply 10 minus, yeah, coming here for S2, we'll just name this one as S2, okay? So this is S2, and S2 here the first term is 1 by 11. So 1 by 11 by 1 minus R. So here R is going to be nothing but again 1 by 11. So 1 minus 1 by 11. So this would give you 1 by 11 by, what about 1 minus 1 by 11? That would be 10 by 11, is it or not? So this would be 10 by 11. So that means this will simplify to, I mean 1 by 11 by 10 by 11 will simplify to simply 1 by 10. Yes, I hope you can follow this one also. So let me continue it here. So S2 gives you, I mean this is our S2, right? And that simplifies to give us 1 by 10. Okay, all right. So that means we have simplified to the shortest form possible. Okay, and we have some more steps left. So we need to again simplify, once again simplify this. So we can achieve it by doing 4 by 9 into, what about this 10 minus 1 by 10? So this again if you simplify, we will be having 10 tens are 100, 100 minus 1 will be 99, so 99 by 10. So we will finally have 4 by 9 into 99 by 10. Okay, once again we can even simplify this, right? So I can cut this 9 and 99 for 11 times. And next I can cut this 4 and 10. This is 2 2s are 4 and this is 2 5s are 10, right? So hereafter we will not be able to cut with any numbers. So finally we will be left with 2 into 11, which will be 22 divided by, we have the denominator which just 5. So 22 by 5. This is going to be the most simplified, I mean the very simplified answer. The simplified answer is going to be 22 by 5 is going to be the answer for this infinite series. Okay, I hope you believe it to be an interesting, the way approach we solved it to be very interesting, right? So 22 by 5 is going to be the answer, and we have our answer available at option C. So option C, 22 by 5 is going to be the answer for this interesting sum up to infinity equation. Okay, yes, as I told, I hope you enjoyed this problem, and also if you feel that this session was useful, please give a like, and if you feel this session to be useful for any of your friends, please do share this video to your friends also. Again, we'll catch up in the next session with some other interesting question. See you soon there. Thank you so much.